Good morning, guys. Welcome back. I've missed you guys, and I hope you guys are doing well. So today's lesson will be on how to use trigonometric ratios to find the side lengths in right triangles. Okay. But before we get into our lesson for today, I want to go over the problem of the day questions, which is basically the exam questions that you guys didn't perform too well on. And of course, if you have any questions along the way, please email me or send me a comment on Google Classroom between the hours of 10 and 3 p.m. from Monday through Friday. Okay, so let's begin. So the first one, it says, in right triangle PRT, the measure of angle P is 90 degrees, altitude PQ is drawn to hypotenuse RT, RT is 17, and PR is 15. Determine and state to the nearest tenth the length of RQ. So what they want us to find is part of this hypotenuse here. Okay, so they want us to find X, or in this case, RQ. So immediately after seeing what the givens are, I notice that I'm using the half moon method that I taught you guys, all right, in order to set up your proportion. So it's going to be 17 over 15 is equal to 15 over X. And then when you cross multiply, you're gonna get 17X is equal to, let me get my calculator. Should be 225, but let me double check. Right, 225. And then you do the multiplicative inverse of 17. So X is equal to 13.23529412. And it says to round to the nearest tenth. So the nearest tenth is right here. I look at this number, it's less than 5, so I just leave it as is. So RQ is going to be 13.2. And that's our answer here. Okay? Again, you're using the half moon method, all right? You're setting up your proportion, cross multiply, and then solve for X. And then don't forget to round at the end. All right, moving on to the next question. It says, campsite A and campsite B are located directly opposite each other on the shores of Lake Omega, as shown in the diagram below. The two campsites form a right triangle with Sam's position S. The distance from campsite B to Sam's position is 13,000 yards, and campsite A is 1,700 yards from his position. What is the distance from campsite A to campsite B? All right, to the nearest yard. All right, so as you can see here, all of the answer choices or the dimensions are already in yards, so we don't have to do a conversion. But we notice that this whole thing is a right triangle and we're missing a side. So whenever we have a right triangle and we're missing a side, that means that we can use or employ the Pythagorean theorem, which is a squared plus b squared is equal to c squared, okay? So now we're looking at what our givens are. And we notice that we have the hypotenuse, which is going to be our c squared. Please don't forget that the hypotenuse is opposite the right angle and it's the longest side of the right triangle. So we get 1,700 squared here, and then let's put b squared here. So we're gonna get 1300 squared, and then a squared will be x squared, or you can just leave it as a squared. Now you bring down the a squared plus, and what's 1300 squared is gonna be a rather large number. So you get 1,690,000. Wow, that's such a big number. And then 1,700 squared is gonna be an even bigger number. So you get 2,890,000. Now, as we know, in order to solve for a squared, we have to do the additive inverse of 1,690,000. So you end up getting a squared is equal to, let me just do the subtraction. So you get 1,200,000. And then you take the square root on both sides. Some of you guys are forgetting this step. So you get a is equal to, let's take the square root of 1,200,000. And you get a decimal, so you get 1,095.445 ... and of course you have more. And it says to round to the nearest yard, so the nearest whole number we're gonna round to. Okay, so this number is 4, approximately. The distance is going to be approximately 10.9. .96. Okay. All right, any questions? And the reason why I'm rounding up is because if you look at here, this rounds to 5, and this is going to round to 5. Since this is 5, this is going to round to 6. Okay. All right, moving on to the next example. It says, in the diagram of triangle ABC and triangle EDC below, segment AE and segment BD intersect at C, and angle CAB is congruent to angle CED. Which method can be used to show that triangle ABC must be similar to triangle EDC? Now I'm looking through my answer choices, and I know that I've learned about triangle similarity, and I know that HL theorem only applies to triangle congruency, so I'm gonna just eliminate that answer choice off the bat. So I'm gonna work with all of these different postulates and theorems given the information. So let's go back here. Let's see what it says. It says that segment AE and segment BD intersect at C. So whenever we have intersecting lines, this is going to create a vertical angle here, and vertical angles are congruent. Now they tell us that angle CAB, which is right here, is congruent to CED, which is right here. Well, look at these two triangles. If we were to separate them, we know that we have two corresponding and congruent angles. So by angle similarity, those two triangles will be similar, okay? A lot of you got question number 6 wrong. Please go back and change it if you can. Because yeah, that's the only way that you can prove that those two two triangles are similar, okay?